Hello and welcome to the second lesson of the Big Data Hadoop Administrator course offered by Simplilearn. This lesson focuses on Hadoop ecosystem components. Let us look at the objectives of this lesson in the next screen. You will be able to explain the concepts of Ganglia on a cluster along with installation, configuration, and usage. Install and configure Nagios to gather sample alerts and monitoring. Install, configure, and use Sqoop. Overview, architecture, and usage of other ecosystems like Oozie, Avro, Thrift, REST, mahout, Cassandra, Yarn, and MapReduce 2. Discuss Hadoop security concepts, Kerberos integration with Hadoop, its concepts, and configuration. Let us start with the first topic in the following screen. Ganglia is an open-source, highly scalable monitoring system for high-performance systems such as clusters and grids. It is designed mainly for amalgamations of clusters. It uses XML to represent data, portable data transportation via XDR, and data storage and visualization using the RRD or round-robin database tool. It uses data structures and algorithms to achieve high synchronization. It has been used to link clusters across various sectors all over the world. Let us look at the components of Ganglia in the following screen. Ganglia Monitoring Daemon, Gmond. It is a mandatory requirement that needs to be installed on each machine that needs to be monitored. In the context of our lesson, it would be the slave and master. Hadoop nodes and Gmond service collect server metrics and transfer to TCP. Ganglia Meta Daemon, Gmetad. The Meta Daemon surveys all the available Gmond data sources over TCP and makes the data available for the web interface. A dedicated server is used for the assembly and demonstration of the assembled metrics. Ganglia Web Application provides a PHP-based web app that displays different visualizations of server performance over various periods of time. In the next screen, we will look at the steps involved in installation of Ganglia for Hadoop Server. Ganglia installation is a three-step process. The first step is to install the Ganglia RPMs. Then install the Ganglia configuration files. Finally, validate the installation. Let us look at the different Ganglia Web Interface tabs in the following screen. The Ganglia Web Interface provides a number of graph options to visualize the data it collects. The main tabs of the Ganglia Web Interface are 1. Main 2. Search 3. Views 4. Aggregated graphs 5. Compare hosts 6. Events 7. Automatic rotation 8. Live dashboard 9. Mobile. These tabs help in easy navigation across the various Ganglia interfaces. We will look into the various types of Ganglia graphs in the next screen. Let us start with Grid View. It is the highest level of view. Grid graphs summarize data across all the clusters present. Next there is Cluster View. It represents the Gmonds, that is, the hosts in the cluster, according to physical location, common workload, or any other criteria. Host View represents the textual information of the metrics from a single Gmond process. Physical View is a text-based representation of all the hosts in the clusters. Node View is a text-based representation of a single node. This screen gives an overview of Nagios. Nagios is an open-source monitoring system designed for large clusters, that is, hosts, services. It can also monitor routers and switches. Nagios provides a supple framework for gathering data and information for tuning your cluster, including network, disk, and CPU utilization across machines. The main functions of Nagios are 1. Giving information about the Hadoop infrastructure. 2. Spotting and fixing problems and analyzing future issues. 3. Enhancing the inbuilt monitoring capabilities to receive notifications for potential problems. 4. Evaluating specific trends like the CPU usage for a particular time period of Hadoop service. In the next screen, we will discuss how to install Nagios. Nagios can be installed and configured using the Ambari installation wizard. The two most common ways of installing Nagios are 1. Using a package manager. 2. Building from source. We will discuss the building from source method in this lesson. Let us look at the installation steps in the following screen. The steps of installation are: first, use the command given on the screen to install Nagios packages. To access the Nagios web interface, configure Apache as shown. Edit \etc \nagios3 \nagios.cfg and customize check _external _ to 1. For Nagios and Apache permissions, type the commands shown on the screen. Next, check the Nagios UI using the commands shown on the screen. In the next couple of screens, we will understand how to configure Nagios for Hadoop alerts. Out of the box, Nagios alerts cover a broad range of Hadoop environment and are displayed on Ambari web interface. The out-of-the-box functionality provides some standard alerts. However, as an administrator, one might be required to create new alerts to cover business rules and logics. The steps to configure Nagios for Hadoop alerts are listed here. The first step is to create a Nagios plugin script /executable. Next, save your plugin to the plugin directory on the Nagios server machine. The third step is to define the command and execute the new plugin. Next, decide which host group your plugin should check. Decide which service group your plugin belongs to and define the alert entry. Finally, restart the server. This screen gives an introduction to Sqoop. Sqoop is a command line tool which is used for transferring data between Hadoop and specified relational databases. Whereas importing is the process of bringing data into Hadoop, exporting is the process of taking the data from Hadoop and putting it back into the system. Sqoop can manage both of these processes by using the Sqoop import and Sqoop export functions. The important features of Sqoop are: Sqoop allows transferring bulk data from relational databases to Hadoop. It allows importing data from external structured data stored into HDFS or ecosystems. In the next screen, we will look into the advantages of Sqoop. First, Sqoop allows data imports from external data stores and enterprise data warehouses into Hadoop. Sqoop parallelizes data transfer for fast performance and optimal system utilization. Sqoop can copy data quickly from external systems to Hadoop. It makes data analysis more efficient and mitigates excessive loads to external systems. In the next couple of screens, we will look into installation and configuration of Sqoop. 1. Download the Sqoop 1.4.4.bin _Hadoop-1.0.0.tar.gz file from www.apache.org/dyn/closure.cgl/sqoop/1.4.4. 2. Unzip the tar file using the command shown on the screen. 3. move Sqoop 1.4.4.bin Hadoop -1.0.0 to Sqoop using the command shown on the screen. 4. Create a directory Sqoop in usr \lib using the command as shown. 5. Go to the zipped folder Sqoop -1.4.4.bin _Hadoop -1.0.0 and run the command shown on the screen. 6. Go to root directory using cd command as shown. 7. Open bash rc file using the command shown on the screen. 8. Add the lines shown on the screen. 9. To check if the Sqoop has been installed successfully, type the command shown on the screen. 10. Download mysql-java-5.1.2.8-bin.jar and move to the displayed location using the command shown on the screen. 11. Log into MySQL using the command shown on the screen. 12. Log into Secure Shell using the command shown on the screen. 13. Start Hadoop using the command as shown. 14. Run the command shown on the screen. In the next screen, we will look into importing data from MySQL. The steps to import data from MySQL to Hive are as follows. First, create a table in Hive. Next, SSH into any Hadoop node and switch to HDFS user. Enter or log in to the Hive console. Create a Hive database and table similar to the MySQL table. Start the import of WP users to Hive. Track the import progress. Verify if the HDFS directory shown on the screen has been created. Verify the imported data inside Hive. In the following screens, we will have an overview of other ecosystem components. Some of the important Hadoop ecosystem components are Oozie, Avro, Thrift, REST, mahout, Cassandra, Yarn, MR2. Let us look into the concept of Oozie in the next screen. Oozie is a Java web application that helps in scheduling Hadoop jobs. It consolidates different jobs successively into a single unit of work. It is compatible with Hadoop jobs for MapReduce, Pig, Hive, and Sqoop. Types of Oozie jobs. 1. Oozie workflow jobs, which are directed acyclical graphs, or DAGs, that specifies a sequence of actions to execute. 2. Oozie coordinator jobs, which are intermittent Oozie workflow jobs that are initiated by time and data. Let us look at how Oozie works in the next screen. Oozie helps to form complex data transformations from multiple component tasks which provide better control over complex jobs. Oozie prompts workflow actions while MapReduce runs them. This helps Oozie to enhance other functionalities like load balancing and failure handling. When Oozie begins a task, it assigns an exclusive callback HTTP URL to the task, which notifies that URL when it is complete. Oozie helps in modeling workflow execution triggers in terms of data, time, or events. In the next screen, we will look into the concept of Avro. Avro is an open-source data serialization and data exchange system. Using Avro, big data can be exchanged between programs that are written in various languages. It has a compact data format, which is language independent, and does not require code generation to read or write data files. Features: schema-based, language interoperability. Avro schemas are described with JSON, which helps in implementation in languages that have JSON libraries. By default, the Avro server uses port 9090. We will look into the concept of Thrift in the next screen. Thrift is a software framework designed for adaptable cross-language services advancement that consolidates a product stack with a code generation engine to create services. It is a dualistic communication procedure. It is an interface definition language used to develop services for various languages. It is a remote procedure call RPC framework and was designed and developed at Facebook for scalable cross-language services development. To start Thrift on your system, use the code shown on the screen. To stop Thrift, type the next code as shown. In the next screen, we will look into the concepts of REST. Hadoop gives a Java local API to help record framework operations. For example, make, rename, or erase documents and registries, open, read, or compose records, set consents, and so forth. This is extraordinary for applications running inside the Hadoop batch, yet there may be utilized situations where an outer application needs to control HDFS. Some examples include making registries and compose documents to that registry, or read the substance of a record put away on HDFS. Web HDFS IDEA is focused around HTTP operations like GET, PUT, POST, and DELETE. Operations like open, get file status, list status are utilizing HTTP GET. Others like create, mkdirs, rename, set permissions are depending on HTTP PUT. Attach operations is focused around HTTP POST, while delete is utilizing HTTP delete. In the next screen, we will look into the concepts of mahout. Mahout is a collection of machine learning algorithms executed along with Hadoop, using the MapReduce hypothesis. Machine learning is the branch of artificial intelligence which focuses on aiding machines to run without being programmed, which improves the machine performance. Mahout enables the data science means to observe meaningful patterns in the big data sets stored on the HDFS. Features of mahout include collaborative filtering, clustering, classification, frequent item set mining. In the next screen, we will discuss the concept of Cassandra. Apache Cassandra is a freely distributed, high-performance, extremely scalable, and fault-tolerant post-relational database. It is designed considering that system or hardware failures can occur. Cassandra follows read or write anywhere design, which makes it different from other ecosystem components. The benefits of Cassandra are that it performs online transaction processing, or OLTP operations, and online analytical processing, or OLAP operations, and it helps to modify real-time data and perform data analytics. Apache Cassandra is used for the following characteristics. It has direct features to scale from gigabyte to petabyte storage. It improves performance with the addition of nodes. It has no single point of failure. It allows easy distribution and replication of data. It supports multi-data center and is cloud capable. It supports multiple languages and platforms. It can directly work in commodity hardware and does not require any special hardware. We will discuss the concept of YARN in the next screen. YARN stands for Yet Another Resource Negotiator. Yarn is the part of Hadoop that helps multiple data processing engines to handle data stored in a single platform. Yarn manages distributed applications. It comprises of a principal resource manager, which determines all existing cluster resources, and a node manager, which depends on the resource manager and manages resources present on a single node. Let us understand the concept of MR2 in the next screen. MR2 is the second version of MapReduce. It is similar to MapReduce execution, but the enhancement in this version is that here each job controls its own operation through its own application master, thus managing the execution flow. It is more robust and scalable than the MR1 system, as a singular job tracker manages all the resource management, scheduling, and task monitoring work. MR2 and the distributed shell are the first two applications which use the Yarn API in CDH4. In the next screen, we will look into Hadoop security. Security is a very important aspect of Hadoop on account of the huge volume of confidential data. Initially, Hadoop technologies like HDFS and MapReduce clusters were used by a group of users within a secure environment which did not require much security, and hence the main security concerns were preventing accidental data loss, rather than to prevent unauthorized access to data. The earlier version of Hadoop did not have a secure authentication mechanism to restrict the access to the data to limited users whom they trusted. However, regulatory compliance for data protection demanded a need for a secure authentication for shared clusters, which led to the development of better security features. In the next screen, we will understand the concepts of Kerberos and Hadoop. For better security, Hadoop has implemented two authentication methods which are listed below. 1. Simple. Here the clients must specify a username. Users who want to work on HDFS or MapReduce jobs have to use their Linux username. 2. Kerberos. Here the HTTP customers use HTTP simple and protected GSS API negotiation mechanism, SPNEGO, or designation tokens. In the next screen, we will understand why Hadoop security is important. Hadoop has the capacity to handle immense measures of data, any sort of information, rapidly. The key reason for security to be one step ahead is due to heavy volume of data coming particularly from social networking and computerized sensors. Other reasons include ease. The open source skeleton is free and uses merchandise equipment to store expansive amounts of information. Figuring force. Its appropriated processing model can rapidly prepare huge volumes of information. The more registering hubs you utilize, the more handling force you have. Adaptability. You can undoubtedly develop your framework just by including more hubs. A little organization is needed. Capacity adaptability. Unlike other conventional social databases, you don't need to pre-process information before putting it away. Also, it can incorporate unstructured information like content, pictures, and features. You can store as much information as you need and choose how to utilize it later. In the next screen, we will understand the concepts of Hadoop's security system. Hadoop security follows a multi-layered approach. Each layer has a distinctive set of security methodologies and strategies. These are listed in the illustration on the screen. Let us discuss the strategies in Hadoop Integral Security Layer in the following screens. Hadoop gives a few security control characteristics. Frequent upgrades of Hadoop are required for better security. Following are some of the crucial security characteristics accessible in Hadoop. Remote Procedure Calls, RPC connections. To commonly confirm the clients, simple confirmation and security layer, SASL/Generic Security Services Application Programming Interface, SASL/GSS-API, is utilized for Kerberos usage on RPC association. Hypertext Transfer Protocol, HTTP Web Consoles. A pluggable HTTP client confirmation component permits conveying associations to arrange their own program-based confirmation for job tracker's web user interface. This could incorporate HTTP simple and protected GSS API negotiation mechanism SPNEGO confirmation. Delegation tokens. Initial confirmation to name node is carried out using Kerberos qualifications. From that point, the client acquires appointment token for consequent confirmation to name node without using Kerberos key servers. HDFS file permissions. Name node authorizes access control to HDFS documents focused around document authorizations. Task authorization. Job tokens. Job tokens are made by the job tracker and imparted to its related task trackers. This guarantees that the undertaking tracker performs undertakings doled out by its related job tracker only. Data block control, block access tokens. When clients need record gets on name node, record consents are checked. The name node issues block access tokens utilizing hash-based message authentication code, HMAC SHA-1, that could be sent to the data node for square get-to demands. This associates the HDFS consents and access to information squares. RPC encryption. RPC associations in Hadoop use SASL, which underpins encryption. Data transfer protocol. Data transfer between customers and Hadoop administrators can be arranged for encryption. HTTP secure, HTTPS encryption. Data exchanged over HTTP convention is scrambled by utilizing Secure Sockets Layer, SSL-HTTPS. SSL can be arranged to verify the server and the customer. Shuffle encryption. Shuffle is the information development in the middle of mappers and reducers over HTTP convention. In the next screen, we will understand OS layer security. The Hadoop record framework is like a portable operating system interface for Unix, POSIX document framework, and gives directors and clients the capacity to apply document consents and control read and compose access. The interconnect of the base operating system, OS, and Hadoop bunch is an alternate layer which must be secured. Enormous data applications are normally sent on Hadoop base that dwells on top of the OS. It is vital to consider OS clients, batch approaches, and record authorizations at the OS layer, while securing the Hadoop cluster for overcoming the OS-related concerns. Hadoop ought to be arranged utilizing a client ID, which is not the root client or is not piece of the root client's bunch. This client can go about as an issue client for Hadoop name node and can have the rights to begin and stop Hadoop forms. In a Hadoop environment, a few clients, specifically HDFS, MapRed, Yarn, are made within the establishment. In the following screen, let us understand data transfer and integration layer security in detail. The main layer of security is the integration of various source systems and Hadoop environment. For data ingestion into and scattering out of Hadoop, there are diverse strategies and methods which can exchange data over and over again from source frameworks. Apache Flume. Flume can be utilized for gathering, conglomerating, and moving a lot of information from various sources into HDFS. In the event that various clients need to exchange the information utilizing Flume specialists to HDFS, intermediary clients can be made and mapped to a single chief client. Then again, Kerberos main can be utilized to get Hadoop specifically. Apache Sqoop. Apache Sqoop can be utilized to exchange information to and from social databases to Hadoop. It gives part-based access and execution limitations utilizing administrator parts. This authorizes confinements on execution of exercises like import and sharing information by end clients. Let us continue to look at other methods in the following screen. External tools. Extract, transform, and load, or ETL instruments, or custom-assembled applications can interface with Hadoop information stores like HBase or Hive. These information stores help Kerberos, Lightweight Directory Access Protocol, or LDAP, and custom pluggable confirmation. The outside application can get to Hadoop as itself or by imitating the associated client utilizing intermediary benefits which can be arranged in Hadoop. File transfer. Secured File Transfer Protocol, or SFTP, is a great alternative for information exchange. Likewise, if FTP server is to be utilized, it will be ideal to utilize single-client access of the FTP server or utilize intermediary client certifications. In the next screen, we will understand what Kerberos is and how it works. Kerberos is an open-source network authentication protocol which is used to authenticate the user. Kerberos for authentication was first implemented in the 0.20.20x version of Hadoop. The Kerberos Ticket Exchange Protocol is a three-step process and is described below. Authentication. The client authenticates itself to the authentication server and receives a time-stamped ticket granting ticket, or TGT. Authorization. The client uses the TGT to call a service ticket from the ticket granting server. Service request. The client uses the service ticket to authenticate itself to the server that provides the service that the client uses, which can be either the name node or the job tracker. The client must undergo the above three steps in order to access a service in Hadoop. The authentication server and the ticket granting server together make the Key Distribution Center, or KDC. In the next screen, we will understand how to configure Kerberos security. The Kerberos installation and configuration steps are: first, install Kerberos using the commands displayed on the screen. After installing the server, edit the main configuration files whose locations are displayed on the screen. Copy the updated version of /etc /krb5.conf to each node in your cluster. Let us summarize what we have learned in this lesson. Ganglia is an open-source, highly scalable monitoring system for high-performance systems such as clusters and grids. Nagios is an open-source monitoring system which provides a supple framework for gathering data and information for tuning a cluster, including network, disk, and CPU utilization across machines. Sqoop is a command line tool used for importing and exporting data between Hadoop and specified relational databases. Oozie is a Java web application which helps in scheduling Hadoop jobs and consolidates different jobs successively into a single unit of work. Avro is an open-source data serialization and cross-language data exchange system. Thrift is a software framework designed for adaptable cross-language services that consolidates a product stack with a code generation engine to create services. Mahout is a collection of machine learning algorithms executed along with Hadoop using the MapReduce hypothesis. Cassandra is a distributed storage system for handling large amounts of organized data distributed across various commodity servers. In MR2, the second version of MapReduce, each job controls its own operation through its own application master. For better security, Hadoop has implemented two authentication methods, Simple and Kerberos. With this, we have come to the end of this course. Thank you and happy learning.